Hello, it's live time again, Tuesday evening. I'm all mic'd up, hopefully you can hear me. Hope everyone is okay this evening. I'll just wait around, see for a couple of minutes, see who's going to join us. I'll just finish my tea, hopefully my voice won't get too croaky. How is everyone? Are we live?
Live on the page.
Quite awkward not having the little thing we used to use.
Facebook for you.
Oh, it does that. It has these things and then gets rid of them. They're not for the better most of the time.
You've got people jumping on. Justin's here, Pam's here, Christine's here, Sharon's here.
Hello,
here.
Everyone okay?
There you go.
You have to tell me if I'm getting too close to the camera as well. Right, let's grab this lot.
Can everybody hear Mark okay?
Excuse me. You hear me? Yeah, switched on, I think.
Let's know if the sound's alright.
Testing.
Lighter version of what I normally say. Yep, Justine says sounds good. Pam says, yep, can hear you okay.
Sounds good to me.
And Sharon says hers is fine as well.
Hello, everyone. Tonight I thought we'd talk about another ingredient that's in all our household and everyday products that we use. This time it's SLS and SLES. So SLS stands for sodium lauryl sulfate and SLES stands for sodium lauryl ethoxysulfate or ether sulfate, whichever you want to use. And that's the structures of them. So you've got what you'd call a long fatty chain with sulfur and a salt on the end. So when you have something like that, that's what we call a detergent. That's what it's used for, or a surfactant, pretty much the same thing. Where does this stuff come from? Predominantly, it comes from palm oil, which I'll come back to later on at the end of the live. But you know, that's the main source. It does come from other places like coconut oil, and they can even synthesize it synthetically from crude oil. So that's what it's made from. What's called lauryl alcohol. So I'll quickly go into how it's made in a second. But yeah, so it's used as a detergent, and this is a list of just some of the things it goes into. It's unbelievable how many things it's used in: body washes, soaps, cosmetics, shampoos, conditioners, cleaners, household stuff, car cleaners, shampoos, all that kind of thing, cleansers, pet care, believe it or not, creams and lotions, and unbelievably it's in toothpaste. I'll come back to that one as well. And it's in mouthwash. So basically anything that's kind of soapy or washy, chances are they'll use this stuff in it. Right, so what's the difference between these two? They're often used in combination or one or the other. So chemically, they're very similar. You've got, like I say, a fatty chain and a salt on the end. But with this one, you have these ethoxy links here. That's the only difference, really. And the N can be any number from 1 up to however many they want to put on, 10, 20. But it's usually in the kind of 5 ballpark. But that is very interesting when it comes to the toxicology of each of these. So today I'll just stick with this part of it and kind of ignore that for now, because I'm going to do another live where I'll explain why I've left that out, and there are other products in all this kind of thing that are similar, so I thought I'd cover those together. I thought I'd quickly run through how they make this stuff. I'll just get rid of that. It's like being back at school. No talking at the back there.
None of my teachers were as good as you were.
Yeah, they're always up for a detention. So I'll just pull that down a sec. Actually, while I've got that in my hand, let me just show you this while it's in my hand. I won't read these out. I'll bore you with all that, but oh well, is that coming up all right?
Yeah, well, you can see how many there are.
This is a list of the different names that this stuff has in all the different products. So these are basically how they disguise it. All different trade names, you name it. That's one side. There's the other. So I just thought I'd show you that. So I can post this list somewhere, can't I, later on. But yeah, just to be aware of that, there's lots of different names. So right. That one over there for now.
Sharon's just told her hubby she's having a chemistry lesson.
Right, so what they do when they make this stuff, I want to mention how it's made, because again, there's lots of steps in the process, and it's not great for the environment because of the chemicals they use. So it's called L'Oreal, but that just means it's got 12 carbon chains, so I'll do those shorthand. Yep.
Tom's hubby's listening as well. Hi, Leon.
So actually L'Oreal alcohol. So to change this end group here to the sulfur, what they've got to do is use a very, very strong concentrated solution of sulfuric acid. Or another one they use is oleum, which is how sulfuric acid is made. It's sulfuric acid mixed with sulfur trioxide. It's got to be so concentrated because you can get side reactions, but what they want is to place this on there. So it's basically what they do, they boil it up with this really strong acid, and then that gives out what they call the sulfonate at the end. Got 12 straight away. Yeah, so you get sulfur, that's as the acid. So what they do then, they neutralise that with some caustic, and that gives you the sodium lauryl sulfate, which is a sodium salt. But this, like, it's all very messy, dirty chemistry. This has all got to be produced, the energy it takes. There's going to be waste products, you name it. The reason it's so concentrated is if you don't have it like that, you'll end up with this. Which is just a double bond. I mean, you can react that further if you put more acid in, but to save money and time, that's what they're trying to avoid. So, right, get the product out. Again, dirty, messy process, a lot of energy needed. It's all got to be separated, washed, washings will go down the drain, all that kind of carry on. I'm not really sure what the extraction process for this is. I've not checked that, I'll be honest with you. I imagine they squeeze it, don't they, and cold press it and perhaps extract it with something with heat. So your detergent, what it's used for, if you have a blob of dirt or a blob of grease, what happens is your fatty chain will dissolve in that, so it'll stick to that bit. I'm getting good at this.
I don't want to think you were a chemist or something, though.
No, it's years since I've drawn structures and whatnot properly. I'll put the charges on so I don't get shouted at. So yeah, you use your soap. All this is water. All around here. So you got your blob of grease or your blob of dirt, so your fatty chain will stick to that. And then to wash it away, this bit here, this likes the water. So it sticks to the fat and stays in the water, and that's how it gets washed away. So what's bad about them? That's what they're used for. It's another one that you couldn't make that up, could you? Anyone hear the helicopter? It's really loud, that. Yeah, there's been a lot. It's surprising, actually, because we're constantly told that these things are safe. The likes of the FDA and all that, which is actually in here. But I've downloaded some papers, so it's not just me making this up. I can post all these afterwards. Given what they do and what they're in, it's amazing. So this is from the World Journal of Pharmacy and Pharmaceutical Sciences, who've done a study on its irritating effects, especially when it comes to eyes. I've got a couple of things on that, so I'll just read a bit of this, what this says. Institute of Health and Household Products Directory of Chemical and Ingredients lists over 80 products that contain sodium lauryl sulfate. Some soaps have concentrations of up to 30%, which are reportedly called highly irritating and dangerous, which is a word they don't normally use. Shampoos are among the most frequently reported products to the FDA. Reports, so people are reporting these things to the FDA all the time. Reports include eye irritation, scalp irritation, tangled hair, swelling of the hands, face and arms, split and fuzzy hair. The main cause of these problems is sodium lauryl sulfate. This is very dangerous chemical because sodium lauryl sulfate is used in our soaps, shampoos due to its cheapness. Sodium lauryl sulfate found in our soaps in car wash or even a garage where it's used to degrease car engines. In the same way it dissolves the grease on car engines, it will also dissolve the oil in your skin, which is why it's very irritating, or one of the reasons anyway, which can cause a drying effect. It's also documented that it denatures skin proteins. That's an interesting one, which I didn't know about that until I started looking properly.
You have to explain what you might.
Yeah, I will do, because I've got a thing at the back here. Also allows environmental contaminants easier access to the lower sensitive layers of the skin. So in other words, it's dragging stuff down through your skin. And following on from last week, surprise, surprise, and most worryingly, SLS is absorbed into the body from skin application. Once it's been absorbed, one of the main effects of sodium lauryl sulfate is to mimic the activity of the hormone estrogen. So it's another estrogenic. This has many health implications and may be responsible for a variety of health problems, from PMS, menopausal symptoms, to the drop in male fertility and increasing female cancers, such as breast cancer, where estrogen levels are known to be involved. Studies have indicated that sodium lauryl sulfate enters and maintains residual levels in the heart, in the liver, lungs, and the brain from skin contact. So every time you use one of these, it's building up in your system again. This poses a question of being a very serious potential health threat to its use in shampoos, cleansers, toothpaste. I mean, you swallow that, you're eating it. I'll come back to that as I'll study on that. In absorption, metabolism, and excretion studies, SLS has a degenerative effect on cell membranes because of its protein denaturing properties. So while we're thinking about protein denaturing, so what I read in this, gather from it, is that what I've just shown, what it does to a fat, where it gets in, absorbs, sticks to it, and kind of breaks it up into the water. It's doing the same thing with proteins. So protein is like a polymer chain of amino acids. And because of all the different groups on them, what they usually do is coil up. So you get them like this. And they form like a specific shape usually. Like enzymes are like that, they're well known. They have a certain shape, that's how they work. So things will come in and fit into a certain site, which is like what I said last week about the estrogenic effects. But what SLS does, it comes in and it breaks up these bonds between what hold them together. So your protein unravels. So of course, if it's an enzyme, it's useless now. It can't work. It'll just sit there flopping about. A denaturing protein, the best analogy I can think of is cooking an egg. So an egg white especially is made up pretty much of all protein. You denature it cooks basically. So it turns white and it becomes solid. It's no longer a liquid. That's kind of what's happening here. Probably the reverse though, because it's opening it out. So instead of being a solid, it's turning into a slop. So I mean, you can do that to an egg in acid or heat. Anything like that will do it. Well, there's quite strong evidence for that. So where are we? I do have these in order, but that's gone out the window. Just put that there. So this isn't so much a toxicity study. This is an analytical technique that someone's published a paper on. Now, what the quoting is, how effective SLS is at doing what they want. So what they're actually doing is analysing proteins, but to do the different parts of the proteins, what they've got to do first is this. They've got to break the structure up from that to that so that they can snip it and then analyse it. That is saying what they used is SLS and how effective it is at doing that. That's why they're using it. So there's your proof. I've got a few more examples. I don't need to repeat myself, I suppose, about the effects of estrogen in the environment. But again, every time you use one of these, not only are you getting it on your skin, possibly swallowing it, it's going down into the environment, into our water again. And especially if you have recycled water, like they do in a lot of places in this country, you're drinking it. So every time you use these with that in, we're building it up in the environment, building it up in our bodies. This is a paper that they did a study on the actual toxicity of it, which was using rats. So what they've done basically, they've fed varying concentrations of SLS to rats. And they're saying here that something between 5 and 10% of a solution, if they have, I think it was 1 milligram. Sorry, just bear with me. I think it was 1 milligram. Sorry, 1 gram per kilo. Yeah, there it is. So if the rat has 1 gram per kilo of body weight of this stuff, it kills it. So it's, I mean, there's a lot of things you can have. If you dose yourself with it, it's probably going to kill you, but that really isn't a lot. That'd be a few grams to us, wouldn't it, I think, based on our body weight. So if we ate that every day, you'd be dead. So, yeah, it's not nice. I've made a little note there. So I'll come back to that in a sec. This one is a study that was carried out on some poor little bunny rabbits. But they were basically checking the toxicity of this stuff to eyes. So this is from the Research Journal of Pharmacology and Toxicology again. It was observed that SLS was toxic to the external adnexia of the eye and caused some morphological changes. There was swelling of the eyelid, hyperemia in the conjunctiva, tearing, discharge, photophobia, sensitivity to light, I suppose, and edema, which is filling up with water, swelling, which were visible up to day 5 with optimum changes on day 3. So after 3 days of putting this stuff in their eyes, it was damaging their eyes, ripping into pieces. The effect was dose dependent and significant in animals instilled with the higher dosage, surprisingly. So it's the proof that it is that causing it. The results suggested that SLS was toxic to the rabbit eye, and an increased dose could increase toxic effect on the eye. This study has exposed the effect of SLS on the eye and recommends minimal concentration in cosmetics and household hygienic detergents that can have any direct contact with the eye. What goes near your eye? Shampoos, cleansers, creams,
soaps,
yeah,
body washes,
cosmetics. Did we say that? So again, I can post these things on the site. Yeah, I'll come back to this one because while I was looking, I did actually find a couple of alternative reports, and a big kind of batch of studies was done by this company called Seventh Generation. Now, to look at their website, they've got nice green leaves and all this kind of thing. Oh yeah, we're environmentally friendly soap. So they did a study supposedly and come to the conclusion that SLS was safe. But I looked up this guy who owns it, and he sold it 6-7 years ago. So it is now owned by Unilever, one of the biggest producers of these things and one of the biggest users of these. So read into that what you will.
There's a name for it, isn't there? When you what's it called when you employ somebody to do research, but you tell them what
parameters to use? I don't know.
There's a name for that.
Someone can help us out with that. I can't think of that word. I can think of a few other words that.
Coca-Cola were one of the first companies to do that. They employed researchers to prove that their energy drinks were good for sports people, but said what results they wanted the scientists to find.
There's a lot of it goes on in the scientific field. Scientists are human like anyone else. They can often twist the result to suit them or what it has been known. It's not what you're supposed to do, though, obviously. Yeah, so that's the main kind of effects it has on. It irritates your skin because it disrupts. Not only does it wash the oil out of your skin, it also denatures the proteins, gets through the skin, sits in your body. It can damage your eyes, and it's estrogenic again, which is in my mind, one of the main causes of a lot of problems that a lot of people are having, if not the main one. A lot of these chronic illnesses, not to mention any. I do think it is linked, though. That's my personal opinion. I do think it's linked to fibromyalgia as well. Yeah, so...
Like you wouldn't wash your face and flash, would you?
Well, yeah, I mean, you look at a lot of these formulations, they're all very similar. What goes into, say, a floor cleaner or a surface cleaner, it's pretty much the same what they put in a shampoo. There are differences, obviously. They'll put biocides and things in, but yeah, like Becky said, would you really wash your hair in flash cleaner? Or, I mean, I'm just picking on them. That's the most famous floor cleaner I can think of. Or washing up liquid. Something, would you use that in your hair? Yeah, so that's kind of why they're bad for you and we shouldn't use them.
Question mark. Lisa says, I found sodium chloride and sodium hydroxide in a couple of things. Are these the bad ones?
Sodium chloride is just salt. I think they put that into as like a kind of a buffer type thing.
Like water supplement.
Yeah. But sodium hydroxide is caustic. That's what they use to neutralise this. So the sodium salt. You wouldn't want to get, if that was strong, you wouldn't want to get that on you. A very similar thing is lye. You've seen these people who've been attacked with lye or caustic. That's what it does to you. But it literally turns your skin into soap. That's the same reaction. How soap is made, you boil up a fat or a fatty acid with caustic, sodium hydroxide, that gives you your soap. And it's essentially what this is. It's sodium salt of this fatty acid. Yeah, I'm not keen on using that. It's very strong sodium hydroxide, very strong base. I'll come back to this now. This lauryl alcohol, which mainly comes from palm oil. You've probably seen our boxes. Every single one that goes out has a little sticker on that says palm oil free. And there's a good reason for that. We won't use this stuff. And we won't use anything that comes from palm oil, any of the other products. That stuff goes into food and all kinds of stuff. But in an environmental sense, it's a disaster. It really is. The deforestation, it's the main cause of deforestation now, especially in the prime forests, that few of them that are left. This is a report that I downloaded from, which site it was. It was some doctor, I forget his name, but he set up a foundation about the environment. This one focuses specifically on this nature reserve, which is in Sumatra, I think. This is kind of the last bastion of the orangutan. Pretty much all of it, so the environment has been destroyed now. This is the last place, and they've set this place up to protect it. It's a protected zone, what do they call it, a national park. But recently, they've been going in and they've started chopping it down illegally, unlawfully. But this is what goes on. The drive for this stuff means that even if they get sued, it's worth it to them. We've got to stop using it. We've got to remove the demand. Otherwise, there'll be no forests left, no orangutans. But this here, it shows they've investigated what companies are behind this and who's using the stuff that was unlawfully obtained from this forest area. So you've got Procter and Gamble, Mondelez, how do you pronounce that? Mondelez, Nestle, Pepsi, Nissin Foods, Unilever, Ferrero, and Colgate Palmolive. So all of those companies there are implicit in unlawfully going into this nature reserve, chopping down the trees, burning the ground, and then planting palm oil for a fast buck. And they're just ruining these forests. Are absolutely priceless because they reckon that they're the highest biodiversity anywhere on the planet. So there could be anything. There could be cures for cancer, all kinds of stuff hiding, just sat there waiting for us to discover. And they're coming in with a chainsaw and slashing it and burning it. It's not on. This has got to stop. It really has. It's got to be sustainable.
Quick question from Sharon. She says, is sodium acetostearyl sulfate the same?
No, I don't think so. Different chain length, I think. I'm not sure what acetyl is. Yes, all these old names. I do the IUPAC names. So to me, it's C12, so it'll be dodecyl, which is all those names are on that list, by the way. Yeah, so again, all I can say is that we try and minimise this impact on the environment and on our bodies. All these kind of things. All I can say is try and vote with your pocket. Don't use them. Don't buy them. Remove the demand. Remove the profit, and then it'll stop.
Sarah says, thank you. I'm going to start checking all my products.
Yeah, I would do. They're not nice things. And like I say, the ether or the ethoxy one, I'll come back to. That's an even more interesting case. But chemically, they're quite similar. I think the reason they use the ethoxy, actually, even though they're chemically very similar and do the same job, is this one is a solid. It's like a very brittle, waxy solid, whereas this one is usually like a thick liquid, a bit like washing up liquid. So obviously that's going to make it more able to go into certain formulations that you need a runny liquid. So I imagine that's why they use that one. So that's your SLS and your SLES partly.
Which are none of our products?
No, we won't use any of those. And this is the reason why. I say we're not just playing at it. It's when we say we don't have stuff like this, it is for a good reason, and this is why we're trying to explain why that we use only natural. So not only is it the effect on our bodies, but it's the effect on the environment as well. I mean, the estrogenics in the rivers and things is causing a catastrophe. Fish changing sex and all that. So it's happening to us. Male fertility is right down in it.
It is really dangerous to aquatic life, isn't it?
Yeah.
It's poisonous.
So I don't know. Has anyone any questions?
Justin says, are there any good natural toothpastes? I've switched most of my products now to MCC. It's just a case of reading ingredients.
Yeah. It is difficult. You just got to keep reading. They are out there.
Do you want to mention about what we've done with Wakey Wakey and Rise and Shine as well?
Yeah, we thought while we're on the subject of shampoos and that, we thought we'd kind of try and make it a bit easier for people to get their hands on stuff that doesn't have that. So we've dropped the price for a short while on our Wakey Wakey Rise and Shine, hopefully to get people more aware of these things and hopefully be impressed with how good they are. You don't need this. It's money that's driving it. Yeah, so are they on now? I think
Yeah.
Reduced, but I think is it 10% knocked off?
Down to £9.50.
£9.50. Yeah, normally £10.99. Yeah. Yeah, so that's your SLS and your SLES. There's any more questions?
Lisa says, I've only been using tip to toe as face wash for a week. My skin is already better. There's acids and salt in my old one. Eye-opening when you start realising what they are.
Yeah. All kinds of stuff, yeah. Preservative again. We'll go into some more of those, I think, later on.
What are you doing next week, do you know?
I don't know. I mean, I suppose while it's fresh, I could do the other half of this. People want to watch that.
Yeah, I think that makes sense.
Yeah, so next week I'll probably do...
Next week it gets even more horrific.
So, yeah, I'll do pegs and this sodium lauryl ether sulfate. It's specifically the ethoxy part of it, which is very similar to the peg. So I want to do that, and that's a killer.
Yeah, just start looking at products in your home and see how many have got peg written in the ingredients.
Yeah.
Some description.
And they'll probably try and change the names. Like that list there, they have trade names. And look at them all. So I imagine some pegs will be the same. PEG stands for polyethylene glycol, by the way.
Everyone's really appreciating you doing these ones.
Good, yeah, it's worth it. Get the knowledge out there. And like I say, they know, don't they? I mean, the fact that they're using it in a standard test shows that they know. It's a well-documented, proven technique. Disrupting protein. It's like the one with the one that causes diabetes. God, my head. There's this chemical that they use in laboratories to study diabetes, and they inject it into rats to make them diabetic. And what it does, it specifically targets the beta cells in your pancreas and kills them. They're the things that produce insulin. And this stuff was actually being formed in a lot of the processes they use. Yeah, it's related actually to the PEGs, because what they were doing was using ethylene oxide, and they were using that to sterilize grain and flour. But what happens, it reacts with one of the proteins in the flour. What's the name of that stuff? Begins with A. It'll come to me. But it was forming this compound that they use to make rats diabetic in the flour when they bleach the flour. And they knew about it. So I'm pretty sure all bleached flours are banned now, aren't they?
Yeah.
So that's no longer there. But how many people has it made diabetic before they banned it? Don't you just hate when you can't remember a word? All that stuff. It'll come to me. Well, if there's no more questions, I'll call it a night then. Any questions, babe?
No, I can see. Have you got any other questions for Mike before we go?
Right, okay then. Well, in that case, I'll wrap up. Thanks for joining. Try and hopefully do another one next week on the pegs and that. So you guys take care of yourselves and keep reading, keep looking at your labels. And my advice is to stop using stuff like this that's got these in. And that's not just us saying it, it's for all our benefit.
Leslie quickly, she's put, are all oils dangerous?
No. Depends what you mean by an oil, I suppose, but no, we'll use essential oils, won't we? A lot of those are very beneficial. There's plenty of oils that are good for you.
Everyone's asking, do you make a toothpaste?
I'd love to make all this stuff. It's my thing, and it coming up with new things, but then to try and make it and get it out there at a reasonable price is the hard part. We do what we can. So we're sourcing stuff like this from responsible places, aren't we? Like the coconut oil, and they're slightly different soaps. The cocoa oil, but they work just as well, if not better, and they don't have all the side effects. So again, to me it's a no-brainer. Why take the risk? Right then. So I think we'll call it a night. Yeah, so yeah, keep reading. Watch your ingredients. Look after yourselves. Thanks, guys. Take care.